Before you learn how to find the solution to a system of equations, I think it's important that you understand exactly what a system of equations is. All it is just a set of multiple equations that have the same variables. In other words, it's simply just multiple functions. The solution to a system of equations is simply a point that all functions have in common. That means if you were to plug in the same input into each function, they would all yield the same output. And I want you to keep in mind that not all systems will have a solution. On the other hand, a system may also have infinitely many solutions. You can read the little notes at the bottom of the screen, but I'll briefly explain this later. You'll better understand this once you get a solid holding of what exactly a solution is. Now, if you take a look at this example right here, we've got two lines, 2x plus 3y equals 6, and 4x plus 9y equals 15. The solution to these functions is simply where these two are at the exact same place, where their inputs match their outputs, or where their x's match their y's. So if we draw these two lines, you'll see exactly where they meet. That's the solution to the system of these equations. Now, you won't always have a graph at your disposal, or maybe the numbers are so ridiculously large, graphing everything may not be so practical. That's where algebraically solving comes in. There are two main methods to do this, but I'll only go over one in this video, substitution. I can make another video on elimination later, which is easier in some cases, but I think substitution is a much more generally applicable method. Now then, let's take a look at these two equations. 2y plus 3x equals 38, and y minus 2x equals 12. We want to know where these two lines meet. And to do that, all we have to do is isolate a variable from one equation and plug it into the other equation. So right here, I'm going to pick whatever equation looks easier to isolate a variable. In this case, it looks easiest to isolate y in the lower equation, so I'll just do that. All it takes is simply moving the minus 2x to the other side of the equal sign by adding it to both sides. Now we have to substitute the value we got for y into the other equation so we can solve for x. So replace y on the upper equation with 2x plus 12. And everything up until this point has been done to remove one variable from an equation. If you'll notice, now we only have to solve for one variable, x, on the upper equation. We can simplify what we have now to 4x plus 24 by distributing the two. Combine like terms, move 24 to the other side by subtracting it, then divide both sides by 7 to isolate the x. And now we're left with x equals 2. Great. Now we can choose any equation to plug this x into, and this is because, assuming you did everything up until now correctly, both equations should yield the same output given the x value that we now have. I'm going to choose the lower equation because it looks faster and easier. So replace that x with 2, simplify that to 4, and solve for y by moving that to the other side. And now we have y equals 16. Pair that with x equals 2, and now we have a coordinate, 2, 16. This is our solution. What this means is that if we take this graph right here and plot a point at 2, 16, if we draw our lines, they should meet exactly at that point. And would you look at that? They do. Now, remember I told you about zero and infinite solutions? You might have a clue as to what they are now that you understand solutions. But if not, that's okay. Just know that no solutions are present if two lines are parallel, and a system has infinitely many solutions if the two lines are the same.